Alright, I'm going to walk through a PwnedLabs.io lab. PwnedLabs is a really awesome platform for learning cloud. And I'm going to do the free lab called SSRF to pwned today. And we do have a given IP address that we're given here. So first step in this lab, I'm going to go ahead and do a sudo nano etc host to just get into our etc host file on Linux and then put the IP with hugelogistics.pwn. That's where it's getting redirected to. It gives us that information here, and if you try to put this in, it will direct you here. So we just need to put that into our host file. And by the way, here on Windows, the host file is located in Windows System 32 drivers /etc/hosts, and of course Linux etc hosts. But let's read some of the real-world context and scenario information first. So, rumors are swirling on hacker forums about a potential breach at Huge Logistics. Your team has been monitoring these conversations closely, and Huge Logistics has asked you to assess the security of their website. Beyond the surface-level assessment, you're also to investigate the links to their cloud infrastructure, mapping out any potential risk exposure. The question isn't if they've been compromised, but how deep the rabbit hole goes. Okay, interesting. We do see some learning outcomes about the AWS CLI, web enumeration in SSRF, EC2 instance metadata, S3 bucket enumeration, and then of course mitigations, which is really good to know. Not just be able to do the attack, but how the attack came about and ways to mitigate it. So the real world context here, which is really cool, and most of the pwned.io labs have a real world context. So you're not just doing a contrived CTF, you are actually exploiting things that might have been seen in the wild, so to speak. So the Capital One breach was carried out by exploiting an SSRF vulnerability, which allowed the attacker to send requests to resources that should have been inaccessible, right? Kind of classic misconfiguration. This vulnerability was used to access metadata of the AWS EC2 instance, which then provided the attacker with security credentials for an IAM role that had excessive permissions. This allowed the attacker to access data stored in an AWS S3 bucket that contained sensitive information of Capital One customers. The data breach resulted in the exposure of personal information of over 100 million people in the United States and 6 million people in Canada. The exposed data included names, addresses, zip codes / postal codes, phone numbers, email addresses, dates of birth, and self-reported income. Also compromised were customer status data, credit scores, credit limits, balances, payment history, contact information, and fragments of transaction data. The breach was a major event in cybersecurity and has led to extensive discussions about cloud security, the principle of least privilege, and the appropriate use of security measures like firewalls and monitoring systems. It highlighted the need for organizations to rigorously follow best practices for securing their systems and data. This attack scenario was in part possible due to insecure default settings and is still exploitable at the time of writing. So that's really interesting. So one of the main takeaways is looking at the metadata of the EC2 instance and being able to enumerate through that, and then using that information to then pivot to other areas that you could find other information. So first we're going to do the enumeration phase, and this section is just saying to put in the IP address in the etc host file. So let's go ahead and just look here on the base website first, and just go to the home. So you can see, just scrolling around, clicking around, there's different areas here, but let's just go ahead and look at the page source of the base of the base website here. And just looking here, we can see there is a S3 bucket here at a specific location, but let's go ahead and look at this. The base of it, which is that's not it. The base of it, which is this one, huge-logistics-storage, right? Huge-logistics-storage.s3.amazon AWS. It's right here. So looking at this, we do have some interesting information. It's kind of revealing to us the directories. So we have a backup directory. In the backup, we have a couple files. One of which is the flag, and that's how we're going to solve this. But this looks like CC export. Maybe that's credit card information. There's also a web directory with some images and stuff. Looks like in our case, it could be the backup that's our real loot. Let's go ahead and try to access these things here. If we try to access backup/flag.txt, for instance, we're getting an access denied. And that's okay, but something that this confirms though is that this does actually exist, because it's returning we're accessing something that is there, but we can't get there yet because we have the wrong credentials. All right, so that's kind of the first step of the enumeration. Once again, looking at the base website, looking at the source code, and then kind of looking at other information from there. Also what we can do is run a whois command of the IP address that we're given. So let's go ahead and do that. Pull up the terminal, just a whois with the IP here, and we are given us some pieces of information. It looks like it's an Amazon EC2, AWS, Amazon EC2, so that's really interesting and good information to have. So we might be looking at an EC2 instance. And through the enumeration phase, of course, you're gathering information for possible attack vectors. So we might be thinking in the back of our minds, possibly accessing metadata since it's an EC2 instance. All right, so that's really interesting. So let's keep looking at this website so we kind of can see, there's different areas here, services, about. There's some different places we can go, but if we explore here all the way to status, this is what we're kind of looking at here as a possible attack vector. If we view the page source of this, we can see a form here, and its value is hugelogisticsstatus.pwn. All right, so let's just see what happens when we click the check button. It returns some pieces of information here, but then check out this URL. This is going to be really revealing for the specific attack, SSRF in this case. Also, this might be indicative of LFI or RFI, local or remote file inclusion. What we're looking at right now, though, is possibly SSRF. To read directly from the PwnedLabs information here, but I will read it while we look at this parameter just as a reference. So it says we can assume that the server is taking the value of the name parameter right here, name parameter, and making some sort of request to it. This strongly indicates that SSRF vulnerability may be present, and that unless the user supplied input is validated, we might be able to interact with other backend services. So interesting. So, this was kind of the base, and then when we went to status and clicked it, it gave us this. So it's returning something to us. We saw this in the source code. So we might be able to exploit SSRF with this, with giving it some other parameters. Okay, right now I'm gonna actually go back to the PwnedLabs part just to read some important information directly about EC2 instances that I don't wanna forget. And then also this information that I'll talk about in a second. It says, as our best guess, the website is hosted on an EC2 instance. We can attempt to send an HTTP GET request to the IMDS that is bound to the EC2 private address this. So usually we do enumeration and then we find things, and then we use those things for additional enumeration or possible attack vectors. In this case, we didn't do any enumeration to get this. It was just given to us. All right, so the Amazon EC2 instance metadata provides data about the instance that allow for configuration and management. The type of data are divided into categories, including instance identity documents, user data, or security credentials. Commonly, an EC2 instance can be configured with IAM, Identity and Access Management role, that allows the instance to interact with other AWS services. Admins can also retrieve and use the role's temporary security credentials access key ID, secret access key, and session token from the instance metadata. So that's very interesting. So we can use these things to gain more privileges, so then we can possibly access the things we couldn't access before, right? All right, and so now what we're going to do is just do our first little verification or look at possibly SSRF. So what we're going to do is we're going to, instead of here, which is what we saw in the source code, the value of this huge logistics status.pwn, we're just going to get rid of that. Instead of that, we're going to do name equals, and we're going to give it the IP latest / metadata, because remember, we're trying to look at if it's an EC2 instance, we can access the metadata. And it gives us this. So this indeed is kind of a confirmation that we are looking at an EC2 instance. It's giving us metadata, and we can just see some of the metadata here. Now for the rest of this look at our SSRF, what I'm going to do is actually switch to the terminal and use the curl command just as an additional demonstration that you don't have to use the browser, and sometimes you can, sometimes I like to use the terminal better with curl just because I think it's faster usually, and sometimes with the browser it might be slower or even inaccessible. So let's continue this, and we'll just look at this specific command that we did, but we'll just do it with curl -s. Give it the command. And again, it did return all this metadata here, so we can think, okay, this is definitely an EC2 instance because it's returning actual metadata here. All right, so next command, let's just go ahead, put the arrow up and give a new command, but just modified. So next what we can do is metadata /IAM/info. Right, so we're looking at the metadata IAM info, because remember back in the description it said if we can get the metadata, then we can possibly find IAM information. So let's check it out, and bam, we do get some IAM information here with the instance profile of pwned S3 access. All right, so kind of like a good demonstration here of the workflow of AWS. We first found that it was an EC2 instance with the metadata, just looking at latest metadata, and then we looked at IAM/info to find any IAM info. Now we're going to go through and do metadata/IAM, but this time with security credentials. So we're looking at the security credentials, and then we'll grab this name. So now that we verified it's EC2 and we could see IAM information, now we're looking to see if we can get the security credentials of this IAM information, and bam, would you look at that? We are able to get this information, right? We see the access key ID, secret access key, and the token. We're not quite there yet, y'all, but we can safely say that we have pwned at this point. So let's go ahead, I'll clear the screen. And now what we're going to do is AWS configure, and I'm just going to do a profile of Plato, the philosopher. So AWS configure command, you're just configuring the AWS execution context. So when you do execute anything from the AWS CLI, it'll be through this specific set of credentials. And if we do the profile command, it's just really saying that we want to have a separate profile, because I've have a couple credentials already in here. So just with the separate profile, that'll kind of give you the specific credentials that you want with the profile. So what we can do is just grab, whoops, I need to scroll up here real quick. So we did AWS configure, and now what we're going to do is grab the access key ID. Okay, now secret access key. Grab that. All right, and then this can be default. And now what we want to do is do another AWS configure, but this time we'll do our profile Plato, but this time we'll do set AWS session token. All right, so we did a configure, which just gives us these two credentials, but now we're doing a set session token. And I got ahead of myself, so what we need to do is actually give it the session token. It's not as the same as the first command where it prompts you for it after, so we just have to give it to it in the command directly here. Paste that, it's within quotes, and you can see it looks like it's just a base 64 string here. Okay, great. So now we have this configured and the other information configured. So now let's do AWS STS get caller identity. This is like the who am I command in the AWS CLI or the AWS system. And we're going to do profile Plato because that's what we were working with earlier. And would you look at that, we are now credentialed as pwned S3 access. So just real quick, once we got that information, all we had to do was configure with the credentials and then set the session token to the given session token here. All right. So next step, now that we're credentialed, we can actually start looking at the stuff that we weren't able to before. So just looking at that, it was over here, huge dash logistics dash storage, and the command will actually just look like this. Oh, whoops, I copied it. Let me just retype it. So it's AWS, that's the tool we're using. And we're going to be using the S3 service to ls or list huge logistics storage. And let's see what happens. And oh, I messed that up because we need to actually give it the profile. So we'll do that profile. The profile we're using, and that's why you need to make sure you have the right context, because the profile we're using was with these credentials. And yeah, we do have the backup in web, so let's do that same command but with backup and see if we can ls that. So once again, same command, but now we're doing backup. And that's an interesting mistake here, but what you can actually do is the slashes are important. All it did was just give us the backup. But if you give it another slash, it's kind of saying, okay, give me everything after the backup directory. This was just giving us the backup directory. So just remember that. And bam, look at we can see the CC export and the flag. So the next command is basically pretty similar. We're gonna do CP, S3, and then the site. And let's get the flag.text. The dot just means it's going to be put in the current directory, and then profile Plato. Right, so this is the AWS CLI tool. We're using the S3 service to copy this file, and we're going to put it in the current directory profile of Plato because that's the credentials. And let's see. Yeah, we do have the flag text. I'm not going to cat that file, but that was how you access the flag that you can then turn in. It's an MD5 hash that you turn in to own the lab, which is at the very top here. I'll show you. You can submit the flag right here. But once again, all the steps have been revealed, but go ahead and do it yourself. I do not want to give the flag away directly. All right, and this is just going through what we've seen before. But let's go back here. So that's the flag, but then another kind of proof of concept here is, let's get the cc export 2.txt, same thing. We're using the S3 service to copy this file to the current directory. And we got it, let's see, and let's cat that. And it looks like we do have some credit card information, so yes, we have pwned. And that's very interesting. So let's see what it says in the lab. This gives us all the steps here, and this was the last step that we just did. So we're able to access all this information just from the original starting point, remember, of getting the metadata with the EC2 instance, right? So if you're able to access that, we're able to gain credentials that we're able to then get information that was originally access denied. So pretty dangerous. So some good defensive strategies and knowledge here. If instance metadata is needed, it's recommended to use version 2 as this requires authentication. It's worth noting that a local attacker who managed to gain access to the EC2 instance by another means would still be able to access IMDS v2 and access any stored credentials. Also, if an EC2 instance has already been created with instance metadata, but the metadata is not actually used in an environment, it can safely be disabled using example 2 of the AWS guide. So it gives you information there that you can use to disable. Thankfully, since this lab has been released in September 2023, Jeff Barr in November 2023 announced that AWS has changed the default configuration so that all console quick start launches will use the IMDS v2 only. And there's a tweet about it here. And then it gives us a blog article that he confirms that effective mid-2024, newly released Amazon EC2 instance types will use only version 2 of the EC2 instance metadata service. Previously, when creating a new EC2 instance shown using the AWS console, under advanced settings, there were options to configure various aspects of the metadata service. So looking over here under the advanced settings of creating an EC2 instance of AWS, by clicking info next to the metadata accessible showed that the metadata is accessible by default. Clicking info next to metadata version revealed the text below, right? So prior to AWS changing the default behavior, versions 1 and 2 of the instance metadata service would still be available by default when creating EC2 instances. Version 1 of the AWS instance metadata does not require authentication. As shown in this scenario, any process that can make HTTP requests to that private IP could access IMDS v2 data. The lack of authentication was leveraged in the 2019 Capital One breach. Right, so a couple lessons here. Specifically, you want to be configuring for version 2, you want to be mindful of authentication in this instance, but then you also can take a step back and think, okay, everything should be authenticated during processes. Okay, so another issue that led to this breach is that the entire bucket is listable by anyone in the world. Although AWS does not provide a warning about this setting, there are many examples of S3 buckets online where this setting has been enabled. S3 buckets allow files to be made publicly available without having to grant excessive permissions. And the admins also made a mistake in not properly naming the S3 bucket according to its use and in storing sensitive data on the same bucket as public web server files, right? Storing sensitive data on the same bucket as public web server files. So to read between the lines there, you want to store sensitive data on separate S3 buckets if you're going to use S3 buckets, right? It's a big mistake if you're using public server files with the same S3 bucket. And then it gives us some further reading here. And so that was making the world a better place with PwnedLabs.io and the lab SSRF to Pwned.